This video follows the one called How to Fit S-Curves 1 from a world's expert who uses Excel. The most fascinating aspect of S-curve fitting is the ability to predict the final ceiling from early data. This very fact, however, constitutes also the fundamental weakness and the major criticism of this forecast, because logistic fits on early data can often accommodate very different values for the final ceiling. Alan De Becker and I have carried out an extensive simulation study in order to quantify the uncertainties involved in fitting data with S-curves. The study was based on some 35,000 fits on simulated data, smeared by random noise and covering a variety of conditions. The fits were carried out via the minimization of a chi-square. The study produced lookup tables and graphs for the determination of the uncertainties expected on the three parameters of the logistic function. Today, I will show you how to calculate the uncertainties on the parameters determined by Solver in your S-curve fits. Let us go back to our example of the early days of the COVID-19 diffusion in South Korea. I will show you how to calculate the uncertainty on this value 8605 for the ceiling, which we find with the solver if we fit the data only up to March 1st, which is I wanted to have done in the first video also, but by an oversight, I fitted the whole range. We use the lookup tables in our publication mentioned earlier, which you can find on this URL spelled out here. To locate the appropriate table, we must know the range of the S-curve populated by data. So let's type here the ratio between the S-curve and the maximum, the ceiling. We put $1 on that so it doesn't change when we drag it down. And if we follow to the end of the data, we want up to March 1, we see that we have a 0.4 penetration rate. In other words, 40% of the S-curve is populated by data on this graph. So we'll be using table 3 on this publication here, which corresponds to a penetration level of 40% on the S-curve. In order to be able to use the table, the lookup table, we must also know the uncertainty, the error of our data points. So we can estimate this as the percent deviation between data and S-curve. You can type here equals absolute S-curve minus data point divided by S-curve. And we can drag this to the end of the data. We really should only use the data after January 21st, when the trend begins to develop, because before that, the numbers are too small and the percentages are artificially exaggerated. So now we can calculate the average deviation equals average of these deviations. And here we have an estimate for the accuracy of our data points. In lookup table 3, we will enter the information, the average, the error per data point, and the penetration level. Here is lookup table 3. As you see here, it is appropriate for the range up to 40% of the S-curve, which is our case. And on this line here, we see the error per data. We found ours to be 9 close to this 10, and then, so this is the most relative column. The errors, the vertical scale here is the confidence level. So if we take something like 90% confidence level, which is reasonable, then we find that the error on M is 28%. If it was 10, it's not quite 10. We have to interpolate between the column 5 and the column 9. So there's about 15 points, yeah, about three percentage points off. So I would say the error is around 25%. So for our condition, our data range and our error per data point, and with 90% confidence level, the error on M is plus or minus 25%. Now we can draw a confidence level band on our graph. Let's move the graph out of the way. And let's copy the data S-curve and associated column twice for the two limits of the upper and lower limit for the ceiling. Now, if this is the upper limit, the M here should be equal to the original times 1.25. And if this is going to be the lower limit, then here should equal to the ceiling divided by 1.25. So now we have two curves. You see them here outlining an upper and lower limit, but we should make them continuously with the data. Now we'll call on the solver twice. Once to minimize this target cell here by varying the slope and the T0. You see that got attached very nicely. And then once again, we'll call on the solver to minimize this time this cell here by varying the respective A plus T0 slope and the midpoint of the lower limit. And as you see, we have a nice band, a confidence of 90% confidence level that indicates that all future outcomes of the actual numbers will fall with this 9 times out of 10 will fall with this thin band. We can now check what really happened, because we do have the actual data here. We can do this on this spreadsheet by copying the data from March 2nd onward and pasting them here. And we'll see that indeed they appear within the 90% confidence level band as expected. These are the little blue diamonds.